Hello? Is this thing on? Well, I guess if nobody's viewing, we'll at least have the recording. So, welcome to this stream of me trying to generate railroad diagrams for Python documentation. If you would like to join the voice chat to ask some questions, I put a link in the chat. I will be looking at the YouTube chat occasionally, so you can ask questions there. If you would just like to stay quiet, that's fine too. So what's happening here? There was a post by Baofeng Wang, hopefully I'm pronouncing that right, 5 days ago. 5 days ago about improving the Python language reference documentation. And this is about generating railroad diagrams, which are diagrams like this for Python's grammar. So if you don't know, Python's grammar looks like this. This is the full grammar specification of Python, and it says, for example, let's see that arguments are comma-separated start expressions or assignment expressions or expressions without the walrus operator, and so on. So this file is actually used by Python itself. Let me pull out my editor here. I have Python or CPython checked out, and in a directory called grammar, there's python.gram, which is this grammar file that's just copied and pasted into the documentation. And this file is actually used by Python's parser, or to generate Python's parser. So this is the definitive edition of Python grammar. This is it, and this is correct by definition. The problem with this file is that it is quite confusing because it needs to include everything Python needs to know about the grammar. So it's not just the grammar itself, but it also has some rules saying what to do when a part of this when some part of this grammar is parsed. When this is copied into the documentation, some parts are left out. So we have these invalid rules, like invalid conversion character, invalid class argument pattern, and there's actually quite a few of these which do not appear in the documentation, and they're actually ignored. So what Python does, it will parse your code without these invalid rules, and then if it finds an error, it tries these invalid rules additionally to give you better error messages. Right, so these rules are only there for better error messages, and if we just want the definition of the grammar, we can ignore them. So that's what this file is about. There's another file, there's another version of the grammar in the documentation, which is in the individual files or individual pages of the documentation. Let's open a few of those. And these are pieces of grammar like this. So this says that an identifier starts with xid start, which is basically all letters and the underscore, and it's followed by xid continue, which is basically all letters and numbers and the underscore. And there's a little star that says the xid continue is repeated. So what this means is that identifiers start with a letter or underscore and continue with letters, underscores, or numbers. So there's a bunch of pieces of grammar like this, and these aren't actually used for anything by Python itself. These are just there for the documentation. These are only used in the docs. I hope they're correct, but I don't think we actually have any mechanism to test that they're correct. And obviously they're very simplified. So another question is, if we want to add railroad diagrams or convert these definitions to something like this, which is much easier to follow than the grammar. Let's try to find the grammar for the if statement. Statement says if assignment expression colon suite, which is a block of commands, and there's elif assignment expression colon another suite. This is repeated. And there's else colon another suite. So this should correspond to this one. So there's if assignment expression colon suite, and and then then you can follow these lines to get into as many elifs as you want, or get to an else, or skip this entire thing. I don't think this is actually correct. You should get an else after the elif as well. But, well, we'll generate things automatically, so hopefully our diagrams will be correct. So these diagrams are generated by a tool called Railroad Diagram Generator, which is this web application, and you can also download it as a Java executable archive. I have no idea if my computer can run these without installing something. And the goal here will be to put these diagrams in the Python docs. There are several problems with that. The first one is that we can't really run a Java application when the docs are built, so we'll have to generate the diagrams ourselves, basically. I've done something like that for the dev guide. I have the link in this thread for that somewhere. So this is proven technology. This is a picture that's generated automatically from some data. The way this works is this is an SVG picture. SVG is a text-based format, and that's generated basically the way you would generate an HTML website. So if I look at the page source here, maybe it's all in there. Yeah. So there's a bunch of SVG. It looks kind of like HTML because it's XML, it's the same thing. And it's basically made up of paths, lines, circles. Oh wait, this is not it. This is a different SVG picture. Let's try to find release cycle here. Ah, here it is. That's the one. So this one is generated including comments. It's made of rectangles and text, basically. So this says there's a rectangle of class release cycle row shade. that starts at these coordinates and ends at those coordinates. And that should draw this little gray rectangle here. So this is the kind of thing we want to generate for the railroad diagrams. And the way I'll do this is first write a script that can generate these, and then try to somehow integrate it into the Python docs. I have 2 hours for that, a little less. I'll probably not do very much live here on stream, but I can try how far I'll get. So, how do I generate this? First, I need to get the data somehow. So I need to decide what, which of these grammars I will use. And probably the easiest for me to use right now is the full grammar specification, the file that is actually in Python, this python.gram. And I need to somehow convert this to usable data. For that, I can use the existing parser, which is part of Python's source in, no, not in parser, that's the generated one, in tools, build, no, wait, tools peg generator, this should be it. So there's peggen, which includes like a grammar parser, and includes a metagrammar, which is a grammar for the grammar file, and various utilities that Guido and the team wrote when they moved Python to the new parser. There's a series of blog posts that Guido wrote about how did this. If you're interested in grammars, it's quite nice reading. And I see there's a nice script here called Grammar Visualizer. Wonder what that does. It apparently does some graphics in the text mode. So let me try to run this first and see how far that will get us. So this file is, I'll run it with the just built Python, which is 313 on the master branch, or forked or branched from the master branch, the main branch. And I will run this tools peg generator grammar, is it, no, pegen, I don't know how you pronounce this, and grammar visualizer.py. I get no module named this, so apparently this imports peggen, so I need this directory in my Python path. So that's tools peg generator, and now Python will try to import this, hopefully. Usage peggen age file name. I need to give it a file name. Apparently it needs the grammar description, which is grammar slash python.gram. This is the Python grammar. Let's see what that does. That will give me parse trees like this, and oh, I see we have some conversation, probably for sitting here for a long time. So is the plan to do what me and Hugo did in the dev guide, write a Python script that can generate this so we don't run jars locally? Yes, that's exactly it. So generate SVGs, and no, we don't want to run any Java. Okay, so this has parsed the grammar file and given me these parse trees. So let's see if they actually correspond to the grammar. So the last rule here should have two alternatives. Oh, text is jumping around a bit. Two alternatives, first of which has an exclamation mark, and then it has a positive look ahead that has a group which has two alternatives. One of them is colon, the other one is closing brace, and that's it. That's it for the grammar itself. Then there's the action. If you find this thing, then raise syntax error saying there's a missing conversion character. Right, so this looks correct. And it looks like something I'll be able to use to get the data I need. So let me look at how this is done. There's a main, there's an argument parser, you give it the file name. The main will make an IST grammar printer and print a grammar with it. And it uses build parser from PEGGEN build to build a grammar parser and tokenizer. And I guess the grammar is the thing we're interested in. That gets passed to the sprint grammar AST, which for each rules in the grammar rules print nodes recursively. And what that will do is take a node, get its children, here. So if the node is a list, it will yield from that. Otherwise, it will yield children from the node, basically. And it uses some magic to get these lines correctly. I don't think I'm very interested in that. Right, so I guess I need to copy this part, and then I get to write my own function, or I don't know if this actually uses self too much. It can probably be a bunch of functions that use the data. So let's do that. I will save this as grammar visualizer of Railroad, and try to generate an SVG. So instead of that class, I will have generate SVG from a grammar. Let's see what that grammar is first. So I will call this grammar visualizer Railroad. Pi, what will this do? Takes a while, and then it prints. Oh, the grammar actually has a nice representation that gets printed. This is great. This is nice. So it basically parsed the grammar, and then it unparsed it for me. So this should be the same thing as before. Nice. So let me remove all of that. And what I'll also do is set this up so it runs automatically when I save my file. This is platform specific, and I have a shortcut for it. Now this takes a while. I don't know how much of that is parsing and how much of that is this printing. Let's see if I can print individual rules here. For each rule in the grammar, I will print that rule. Right, so this does the same thing because each rule is on its own line. And it looks like the actual parsing takes the longest time. Oh well, we'll need to live with that. So what do I do with these rules? I will probably need to filter out these invalid ones. If rule.name doesn't start with invalid, not. So this should give me the valid rules. There'll probably be some invalid alternatives left in, and I'll deal with those later. So this is what I'll try to convert into SVG. Let's start with a simple rule here. What's the simplest grammar rule we have? The very first one, not the very first one, the second one says that interactive is statement new line. So let's say that if the rule name is what is this, interactive, I will what should I call this? Do SVG from rule, and then I will break this. So I only do this one little rule. I guess that'll be enough for now. So how do I generate SVG? So the way I like to generate SVGs is to fire up an editor. Put in something that looks like the thing I want to generate, and then look how it appears in the text format. So what I will want to do here is maybe have a rectangle that will have black stroke, and let's say a white fill, and inside it'll have a bit of text with the rule name, and it might have like a line coming out of it. That's this one. Okay. Let's see. So I can save that into my CPython repository and wherever I am, tools, sorted, peg generator, demo SVG, and let's look at how that looks in the text. So do I have the demo SVG? Do I have it here? All right, so this is a bunch of information I don't need. A lot of it is something the editor uses to make this more editable. So let me save it instead as a plain SVG. Nah, this is a bit nicer. Okay, so let's take this. Let's put it in a Python string. I can even indent it since indentation doesn't matter in SVG. And then since I return it here, I'll put it in a little variable and save it in a file. And just to see if I can generate this SVG thingy. So it does stuff. Oh, I forgot to open it for write mode. So this does stuff, and I should have an output SVG here. Oh, I'm not in the correct directory, right? This will be generated in my CPython directory, so somewhere else. Let me open that result SVG in my browser. CPython. Here it is. Doesn't really matter where it is, it will just matter what that I can generate it. I'll integrate it later. So there's apparently an error here somewhere. Firefox doesn't really tell me what the error is, unfortunately. If I look at the source, it looks like a normal SVG. I think the problem is that this XML header needs to be the very first thing in the file. It can't be indented. Ah, there it is. So I'll fix that. And I have a nice little diagram here. Of course, I'll need to generate that. So, for example, instead of rule name here, I will use where's this rule name is here. So instead of this, I'll put in rule.name and make this whole thing an F string. Ta-da! This rule was named interactive, and I have interactive in my diagram. So that's the first part for generating my diagrams. I can only improve this from now on, right? So what I will need to do, and this is probably one of the hardest things I'll struggle with, is, at least when integrating it, is I need to use some font that I can measure. So I need to know how big this text is, so I can get the right size for the box here. And this is a problem if I use the font that Python uses in the docs for code, because what Python uses here, let's see, font family, is UI monospace, which is basically the system monospace font. So this will look different on every computer, and I don't know in advance how big these characters are. And if I want to make this box big enough for the text, I basically can't use this UI monospace. I would need to put some JavaScript in the SVG that would measure the text and then lay out the diagram according to that. So that would be a problem. So what I need to do is, or the best thing I think I could do is to just select some font and do the diagram with that, and then convince the documentation people to serve that or to get that from Google Fonts or something like that. So let's see. Cascadia, Mono, Sega, Liberation, Menlo, Monaco, Consolas. I don't know if any of these are on Google Fonts. I don't know. I probably have this one installed. So let's see if I can use that. So this says font family is sans serif. I change that to this Liberation Mono. Right. And now I have a known font. I have Liberation Mono with a given size, which is 10.5833 pixels. And this will look the same on every computer if you have Liberation Mono either installed or put in the web page header. And oh, Pradyun, you're here. Nice. Yeah, Pradyun says this is the I think my internet went out for a minute. I hope I'm back. Hopefully I'm back. That internet glitch. This diagram is actually carefully constructed to not depend on the font size too much, right? So these these year numbers are pretty small. They shouldn't overflow. These labels have a lot of padding, except for this one, which you can't really read. And these also have a lot of padding, so they should be safe for any reasonable system font you have, which is nice because now they can match the rest of the text here. The diagram looks the diagram looks native. It looks like it's part of the page. If we're doing complicated diagrams, I don't think we could do that. So I'll use this font. Hopefully it's the correct one. Maybe I'll try to parameterize it a bit. What, YouTube chat is moderating out links? What? How do I tell it to not do that? I don't know. Well, if you have some links, you can probably share them in the voice chat window, but I'm not really looking at the chat there. I don't know. YouTube is weird. All right. So what should I look at? PyPI railroad diagrams. Ooh. PyPI railroad diagrams. Should we use this? Railroad diagram generator Python version. Write SVG. Write standalone. Nice. It does terminal. It does things like this. Oh, Well, maybe we should just use that. Let's see. It was released in February. It has a web page. Nice. It's MIT licensed. Maybe we should just use that. And it has the same caveat I was just talking about. SVG can't actually respond to the sizes of content, and there's no way to make SVG adjust saves and positioning. Instead, you guess at some font metrics, which mostly work. Okay. That's probably reasonable. We can force a fixed font if that's a problem. It has a JavaScript module and a Python module. Okay. And here's railroad.py. Is that the thing we use? Yeah. Ooh, it's typed. Wow. Future annotation uses math and sys. Diagram class. Oh, this is sweet. This is the code I wanted to write. I don't know why I missed this. I should not have missed this. That looks like pretty nice code, actually. Okay, let's do this. So this, according to the README, it takes it has basically a DSL. You have to construct some objects, and then you write SVG, give it a write function. Why not? So what's left for us will be to convert the Python grammar to this thing. And I guess one more problem will then be to handle the stuff that this doesn't have. So Python specific README. So we have some components, terminals, non-terminals, comments, empty lines, start and shapes. Okay, we can group things. And maybe we can do with that. If we need something more, then I guess we can contribute to this project, maybe. Does it accept pull requests? Wow, so last year some change was merged. Maybe we can fork it. Okay, let's see. So what do I do? Or do I just install this? Is it safe to install this? I guess I just do. I need to install it into this Python, so I probably need to make a virtual environment. python -m pip install railroad diagrams 3.1. Okay, and now let's replace my thing. Okay, I need to write into this file. I'll return a diagram and then do diagram write svg file.write. Okay, let's see what that does. Gave me an XML file without any style information associated with it. Okay, so I probably need to write some kind of header to let my browser know that this is actually an SVG file. So let's put this thing back in. Right. Nope. What's the problem? Let's look back at the README. There's write standalone, which will format it as a standalone document rather than a fragment. So that's what I need to use. Okay. Wow, this is pretty sophisticated. There we go. All right, so this is a diagram that goes from foo to choice barbaz. Perfect. Thanks, Pradyun. Don't know how I missed that. So what do we do here? Instead of this foo, let's say we put in a wrapper of this rule. Okay. And that'll give us this whole thing, and this way I know, if I see a thing like this, I know I haven't implemented printing out these rules. Okay, I have this diagram. Can I somehow generate multiple of these? Let's see. This is where's the README for this? There's a sequence, there's a stack, optional choice, horizontal choice, optional, one or more group. Can I have multiple independent rules? So list of diagram items. But if I do a list of like 2 of these, it'll probably join them together. Just take a list of diagram items. Oh, this is probably... Huh. Unsupported format string passed to list format, so yeah, this doesn't really take a list. So it takes several arguments and it'll string them together. This one. Yeah. But I want them as separate rules. I wonder if it can do that, and I don't see that in the README here. Can this only draw a single rule? Maybe I should just look at the source. Oh, it depends a start and an end. Sequence, stack, optional sequence, alternating sequence. Maybe I can see that in GitHub here. Have start and end. So can I separate things with start and end? Is this the way? Now just joins them together. I guess this is limited to drawing just one rule. Like, well, I guess it'll work, but I'll need to format things as an HTML document with several diagrams. So if I do just write SVG, I put it in an HTML document and put in what do I need to put in for HTML to be valid HTML? Like start tag and a body. And then I need to end those. Well, looks pretty good, except it doesn't have the CSS, the styling. Let's see. I guess right this default style here. And there we go. Okay. And I will want to do this thing for every rule in the grammar. Oh, this diagram thing should be in there too. And indentation is all wrong. It's Python after all, and I don't want to break. So what did this do? Gave me an SVG. It ends with the SVG, and yeah, I only do that for the interactive rules. So let's do that for all of them. Whoa. It's not an HTML now. Nope. So, let's me skip these weird rules. Now, why am I not getting an HTML document anymore? Oh, I'm looking at the source. I'm a dummy. I am getting the proper diagrams. And all of them. Great, this is the Python grammar. As diagrams. So what I need to do now is to actually walk this tree of or the parse tree and convert that into these diagram classes. So I have this rule, and that is composed of this RHS, this right hand side of a definition, I guess. And this RHS has a list of alternatives which have named items and so on. I will need to walk this tree, and for that the PegGen actually already has some utilities that I can use. I think those will be in this Python generator. No, then PegGen grammar. A grammar file, a grammar module. Defines this grammar visitor, which is a class that lets me walk this entire tree and do something with individual items. So it has a visit, which will get a visitor, call it, and it has a generic visit, which will visit all of the items in a node. So let's see if I can reuse this. And I'll define diagram visitor, derive it from grammar visitor, and it will have a def visit what's this called? Generic visit. And that will just return this this string, this representation of the node. Return wrapper of that node. So now instead of doing this, I will to get the representation of the rule, I will get a visitor. That. And I will make a diagram with the results of visiting that rule. I hope this does the exact same thing as before. Except now I can say that visiting this rule, visit rule, will be the same thing as visiting this first child of that rule, right? I don't know if that makes sense for everybody, if you have ever used visitors in a tree. If not, let me know, ask questions. So what is a rule? A rule is defined in this grammar as something that has a name, type, RHS, some memo, flag, well, I guess these are two flags, and to iterate it you yield the right hand side, right? So the rule always has one child, a node, which is this RHS, and when I'm generating a diagram I can basically ignore this rule and just generate this diagram for the RHS. So I will return the result of visiting nodes RHS. There, and all the nodes here just disappeared. I only have RHS thingies. So how do I visit this RHS? So this RHS, let's look at the definition here. This has some alts, which is a list of some further rules. So I will need to convert this to options in the diagram. Let's see how I do that. I use choice. choice would I use? Yeah. Index argument specifies which child is the normal choice and should go in the middle. We have a PEG grammar, so the normal choice is always 0. That's tried first. So let's try this choice with 0 and the children. Okay, so I will need to import this choice, and in this visit RHS I return choice with index of 0 and visiting every node and this RHS. Let's see. Oh, I imported it from the wrong module. Oh, there's already choice here. Oh, and did something wrong. This will actually give me a generator with just that list of alts. So I need to do give it all the alts. All right, let's see what this gives us. There's a bunch of choices now. Perfect. Now, what is an alt? Well, let me just first verify that this looks correct. And let me look at the last rule here, which says there's a named item called disjunction, followed by if, disjunction, else, something, something. And there are two other alternatives here. And that should match this expression without invalid. That looks correct. Right, so let me turn this alt into a diagram. So what's an alt? Alt is basically a container for a list of items. Okay. So how do I encode that? That'll be the sequence. So I need to wrap the list of items, the alts items, in this sequence. Okay, so I visit an alt and I use sequence. No need for the 0. Use items here. And sequence, I guess, is something I now need to import. Okay. That went fine. And now I have these sequences of stuff. Right, I guess the next thing to convert is this named item, which has an optional name. And the name apparently isn't very meaningful in at least some of the cases. It's none or T or A, so I can ignore that. And then it has an item. So the representation for this will be just the item itself. Right, so if I visit the named item, I visit the node itself. Now this is pretty much the same as this, or not the node itself. I visit the item. Now this is very similar to the rule, it just delegates to whatever's inside the named item. Right, and inside the name item we have this name leaf. And leaf is the final part of the tree. We have either name leaves, which reference other rules, or we have string leaves, which are just strings. So if I visit the named leaf, I need to represent that with a non-terminal instruction or another production. Okay, so non-terminal. And what does non-terminal take? A text and an href. Interesting. I have named leaf here. And this is name. Lost. Name leaf, not named leaf. Name leaf. It has a value, so values is what I need to pass in here. Alright, we have disjunction here. Still we have string leaf here, so let's do the same thing for string leaf. Import that, not with the visit. No, this needs to be terminal, sorry. Terminal. And then we have disjunction if disjunction of expression, which is exactly this thing. Perfect. So I guess a lot of this, a lot of the work is already done for us with this Railroad diagrams from PyPI. So there's still some node types that aren't converted yet, but we'll get to those eventually. Now what I would like to do is add some text to know which rule we're at. Can I do some comments, or do I need to put that outside the diagram itself? I guess I put that outside in this HTML thing. So I write I put it in a div, and I put in the rule name. Okay, so file, interactive, eval, and so on. I'll probably want to do this monospaced. Okay. Great. This looks promising. Now I have this opt, which is an option. Let's look at how this works in the definition. File is statements with a question mark, so all of this is optional. How do I do that in Railroad diagrams? Optional sequence, or just optional? Yeah. So F5 is at opt. I return optional, and what's the name of opt's child? Node. So node.node. I need to import this optional from diagram. And now we have a problem. Object of type RHS has, oh, I need to visit this node, sorry. Optional needs the result of visiting this node. There, statements can now be skipped. Great. Next up, I have this repeat 0, which means this can be repeated 0 or more times. So let's see how to do that with the diagram. There's 0 or more made for us. Okay. So this is not opt, this is called repeat 0. And repeat 0's children are called node again. Okay, there we go. This new line can now be repeated as many times as we want. What's next? There's repeat 1, which in the diagram tool is called 1 or more. That looks good. What's next? Negative look ahead. So this is one of the things that is not really standard in grammars. And the diagramming tool obviously doesn't support negative look ahead natively. And we'll need to do something about that to generate a faithful diagram. And I don't really know what to do with it since we're using this tool. It could work with this group here, probably. A group has a child and a label. So let's go with this and see if we can then style this group somehow to make it obvious that this doesn't actually consume any output. Or maybe we can ask the grammar maintainers if all the negative lookaheads are just optimizations. Right, because this is simple statement, then we ensure that the next token isn't a semicolon, and then we have to match a new line. And obviously, if there's a new line here, we'll probably not have a semicolon. And I wonder if all the cases are like that. So for now, let's visit negative lookahead and render it as a group which has the node, and a label will be negative lookahead. Alright, need to import that group thing. Okay, looks reasonable. If I was building this library myself, I would style it very differently, but we can get to that. Right, What's next here? Gather. This is an interesting piece of the grammar, and we can look at the comment here in the grammar. This is this s.e plus. So in simple statements, maybe we can see it here. It's this one. So simple statements plus, so many simple statements separated by semicolons, right? And this is identical to having the simple statement, and then we repeat the separator and this element. So let's generate a diagram that corresponds to this thing. So the element, and then repeated sequences of the separator and the element. Right. Let's look at the grammar. How they're named. They're named node and separator. So if we visit this gather, then we need to build a sequence that first has the node, and then it will have 0 or more sequences of the separator and the node. Running out of space here. So this is separator. Close all the parentheses. Format this as Blackwood. And yeah, this looks like what we want. If I was drawing this diagram by hand, I would not have this simple statement repeated here. So if I was drawing this by hand, I would probably draw it something like statement here, and then you can continue, or you can have the semicolon and return here. And I don't think I can do this with the diagramming library here. Right, if I make a choice here, I can not return. There's one or more that returns. I guess I could put the semicolon in this place of the bar. Oh, here it is. The repeat argument is optional and specifies something must go between the repetitions, usually comment, but sometimes separators. Perfect. So it has a built-in thing for that. So gather is actually a one or more of the child and the separator. Somebody's need to thank the author of this library. This is perfect. Okay, simple statement separated by semicolons. That's exactly like my little diagram here. Looks perfect. What's the next thing we need to do? The positive look ahead. So positive look ahead is the same thing as negative look ahead, except with a different comment for now. Okay, so there's look ahead. It's probably just an optimization here. If for simple statement we see something starting with the word type, it will be a type alias. If it doesn't start with the word type, don't even bother parsing the rest of this rule and go to the next one, right? Next thing we need to do is this group. So let's see, in simple statement, what are we looking at? Simple statement. So assignment, look ahead, type alias, return statement, and then we have this group. There's these parentheses, and the parentheses are hopefully just a sequence. So let's see how the group is defined. The group inside has a right hand side which has some alternatives, but we already know how to convert right hand side. So the group will just delegate to its RHS. So it'll be the same thing as this rule. And that was this one. So if a simple statement starts with import or from, it will be an import statement. Okay, what's next? Compound statements have a lot of look aheads. Assignments look pretty complicated, but I guess this is what we want. Now, it looks pretty complicated, but I guess it's easier to grok than this. Augmented assignment. Why doesn't that go in wherever it's used? Is that everything? Ah, no, there's this forced object, function def raw. Function def raw has this syntax and what is that? Comments don't say. Metagrammar. Oh, this one, forced atom. So if you do two ampersands in a row, you get a forced object. What is a forced object? It's basically a container for one node, and I guess it does something special in the syntax. Let's see, Python generator. What do you do with the forced? Return self-expect forced. Huh. What is expect forced? It's defined in here. I guess it makes a syntax error. Let's try to use this rule. It says def name, some type parameters, and then we need an opening parenthesis. So I guess if I do def some kind of name and then don't have an opening parenthesis, I get syntax error expected parenthesis, which is exactly the error I saw in the code. So I hope forced just tells the parser that this needs to be there, and if it's not there, then don't continue with another variance. I'm just guessing here. Let's use this group with a comment for that. So for visit forced, we'll just label this and say it's forced. Good enough for now. Function definitions are pretty long. And I guess that's all the node types we want. Hopefully. Let's have this generic visit raise. We're not expecting this kind of node. Huh? Oh, value error. This tilde. Okay. Let's see what's after compound statement in our grammar file. Oh, here it is. Then this one. Oh, here it is. It shows up as cut, and I missed it because it shows so short. So let's see what that is. Commit to the current alternative even if it fails to parse. Okay, so if you have single target, augmented assignment, cut, then Python will never consider this invalid assignment. So if this matches and this doesn't, you get a syntax error and this is not considered. Right, so let's... what do we do for this cut? Can we do something like this again? We don't really have anything to visit. We do an empty group. No, that just gives us nothing. Hopefully with some styling that can work. And that's it. We never get to this value error, so I guess we have all of Python's grammar converted to SVGs now, which is perfect. One other thing that's perfect is if I... So there was a question about if we use a PyPI package, we also need a fallback that doesn't install that for distros. And the fallback for that would be to include this one file, which doesn't really import from anything else. So this whole railroad.py, which is amazing, and I'm in love with it, is just one file Python script and doesn't apparently need anything else. It probably needs the default CSS. No default style. Oh, that's also included in here. It looks pretty self-contained, so Python could just vendor it. Alright, so where do we go from here? We might want to style this a little better. We might want to see what kinds of things are omitted from this full grammar specification. Do we have the lookaheads here? So if I look at compound statements, which has a lot of lookaheads, I don't see them here, which means it's apparently enough for the documentation to not include all of these lookaheads at all. So what do I do for that? Can I return none? And I'll then need to somehow skip it, or will the library skip it for me? That looks like an exception, right? Is there anything in the README that does nothing? Can I have a sequence with nothing? Nope. Sequence needs at least one item. Can I have a list with nothing? If I do that, I do get these empty thingies. Right, so I need to filter well, basically I need to handle none in all of these cases, I guess. Either that or start hacking in the library code itself to allow empty things. This will make the code a lot less nice. I can just add if n here for right hand side and alt, but I'll also need to handle this everywhere else. It'll be a pain. So visit rule visits RHS. So let's say the diagram is this, and I return the diagram. I don't call. I will return none if this is none. Here I only give stuff to choice if it's not none. Sequence the same. Here I don't call any diagramming thing, and here I'm making a new diagram, but I'm not calling visit, so this won't get a none. Here this self visit can now return a none, and I cannot pass that to optional. If this returns none, then I need to return none from opt as well. And I need to do that here. And I need to do that in here. And I need to do that in here for both of these things, probably. Yeah. So if the main diagram is none, let me just assert if the diagram for the main node for gather is ignored in the documentation, how do we format this separator? I don't know. Let's not think about this. Let's brace not implemented error. And then we need to do the same for the separator. And if the separator diagram is none, we just do one or more. Otherwise, we do one or more with the separator. Okay. For forced, we need to do the same thing as for all the other nodes. And somewhere we have an issue. So where's this? After statement new line, we have this simple statement, and this is going to visit rule, visit RHS, visit alt, Right, and this if n is not correct, so I need to filter out the nuns. These result calls. There we go. It's not very readable, but works for now. Okay, so how do these diagrams look? There's some kind of error here. Oh, this needs separator. Right, name. This looks pretty good to me. So let me clean up the code a little. I don't want to print the default style here. I need to keep to my line length. I should probably do something better than this filter. So let's do diagrams like this. And then do write it like that, which might be better for Python people who don't know the filter function. This was items. Okay. Right, so this is looking pretty good to me. What's the next step here? I should probably start talking with documentation people to see if this would be acceptable in the Python documentation. I'll do that in the discourse thread. And the other thing that I could do is start parsing the other kind of documentation, the other kind of grammar, and that's this one. And this has a slightly different syntax than the actual grammar. So these diagrams I could use in this full grammar specification. But if I wanted diagrams for these as well, that'll need to be a bit different. So let me let's see what we should do. So to generate diagrams for the docs here, I'll probably need to collect somehow all of these snippets and then use them in my little tool. So I'll need to somehow get into the documentation build process. How is this actually done in the docs currently? Should be tools, extensions, PG highlight. How's production list, grammar production display. So this is a simple markup that uses this kind of syntax, and it's implemented directly from Sphinx. I guess it shows that Sphinx was made for Python documentation, and this is not really general purpose. And this is documented to use The definition can contain token names which are marked as interpreted text. So in the source, it uses colons, and when it's rendered, this, oh, so this symbol is actually generated by Sphinx. Whoa. Well, that'll be a bit hard to hack into. And I have 5 minutes left, so I don't think I'll get into that today, but I think I'm in a pretty good place with this Railroad Diagrams tool. So I'll continue the conversation on Disqus and maybe do another stream sometime later when I actually get into hacking Python's documentation or the Sphinx extension. So thanks for listening. Thanks for watching me on the stream. I hope I wasn't too slow and nervous for you. Maybe see you around.